Hello everyone. We encounter the states of matter every day. The chair we sit on, the water we drink, and the air we breathe are all examples of matter. In this video, we are going to learn more about the essential states of matter that exist on our planet.
Let's start with a question for you. What is the matter? Matter is everything around us. Everything around us. I mean, the table, the computer, the water, juice, the air, the book, the floor, the plastic, the spoon, me and you. All of these are examples of the matter. Does anyone know or remember what the states of matter are? Actually, everyone knows that solids, liquids, and gases are the three states of matter. But there is a fourth state of matter. Does anyone know anything about it? In fact, there is a fourth state of matter called plasma, which means superheated ionized gas made of positive ions, like this, and free electrons that can conduct electricity. Later, we will explore plasma in more detail. Let's now compare the state of matter using a table in terms of examples, definite shape and volume, arrangement and movement of the particles, and the distance between the particles. Let's start with examples about solids, wood, liquids, oil, gases, for example, water vapor. Could you give me examples of the states of matter? Solids, iron, ice, glass, liquids, milk, water, juice, gases, oxygen, carbon dioxide, and helium gas. Let's start by comparing the states of matter in terms of shape and volume, beginning with solid. Okay, so if wood is placed, for example, this wood, if wood is placed in a container and then transferred to another container, will it change its shape or volume? Let's watch the video carefully and then give your opinion. Okay, does the shape or volume of the piece of wood change when it is transferred between different containers? When it is put the first in the first container, its shape and volume stay the same. Okay, then it is moved to another container and taken out, nothing changes. So if solid in transfer is transferred between different containers, its shape and volume will not change. This means that solids have a definite shape and volume. What about liquids? We will study the change of shape and volume separately. We will start with the shape and ask the same question. Does the shape of liquid change when it is transferred between different containers? Let's watch this video first, then you can share your thoughts. Okay, I will speed the video up a little. When the liquid is in this container, okay, it has one shape, and when is moves to another container, okay, it takes another shape. This means the shape of liquid has changed. Therefore, we conclude that liquids don't have a definite shape and take the shape of the container they are in. What about volume? We notice that when we have a cup of liquid and transferred it between several different containers, then return to the original cup, the amount of liquid remained the same and its volume didn't change. As a summary of this experiment, liquids have a definite volume but no definite shape. Okay, what about gases? I want to show you a video again, then you will find out the answer yourselves. You see this, there is a gas here, there is a gas here, okay, and he pour to another container and bring another container to. Okay, about shape, when this gas is transferred from one container to another, its shape changes because the shape of the new containers is different from the original one. What about volume? We also notice that the volume increases because this container has a volume of 500 milliliters, even though it filled out two another containers with the volumes this of, for example, of 500 milliliters and another this, as you see, 250 milliliters. This happened because gases separate out and fill the entire container they are in. A simple note, the volume of the gas can increase or decrease depending on the container it is in. So we will conclude from this experiment that gases have neither definite volume nor a definite shape, as well as take the shape and volume the container they occupy. Okay, now as a result, solids have definite shape, whereas liquids and gases don't. Solids and liquids have definite volume, while gases don't. Okay, so we will continue to compare the states of matter, but using different terms: arrangement and movement of the particles, distance between them. For example, we will start arrangement with arrangement them and movement of the particles. In solids, the particles, as you see, the particles are arranged regularly and organized in repeating arrangement. They don't move, but only vibrate in fixed positions, like this child is jumping in one spot. What about liquid? In liquid, the particles are arranged randomly, okay, with no regular arrangement, as you see, and are not in fixed positions. I mean that these particles change their positions because they can move around, like these people are walking in a crowded place, okay? In gases, as you see, the arrangement is more random than in liquids, and the particles move freely in all directions. For example, this uh, move in all directions. For example, when you are sitting in one room and your brother sprays perfume in another room, you will smell it. Why? Because perfume turns into a gas when it is sprayed into the air, and gas spreads everywhere in the place it is in, so you will smell it. What about distance between the particles? Look at this picture again and compare the states of matter based on distance between the particles. In liquids, the particles are packed tightly together. It can be said that there is almost no space between them, as you see. In liquids, the particles are close to each other, but there are gaps between them, like these gaps, as you see, like these gaps and this. Okay. What about gases? The particles are much farther apart. Okay, as you see. In other words, the particles in gases are widely spaced, unlike the closely packed particles in solids or liquids. Okay, now another term is compressibility. Compressibility in chemistry means that when press on a matter, its particles move closer together and the matter becomes smaller in volume. Let's start with solids. In solids, as we mentioned, there is no space between their particles, so solids cannot be compressed. For example, if you press on wood, can it be compressed and its volume decreased? Of course, it will not change volume because solid particles are packed tightly and in fixed positions and don't move. This means that solids are incompressible. What about liquids? Although there are small spaces between the particles, as you see, we can't compress liquids because these spaces are extremely small. For example, this experiment, you can do it. Okay, if you fill a syringe with water, okay, and close the end tightly, then try to push the plunger. Will the volume it change? And what can conclude? We can say the particles will not come closer to each other because they are already very close to each other and will not cause any change in the volume. This means that liquids can't be compressed. What about gases? Can anyone deduce the compressibility of gases based on what we have learned in the uh, paragraph about the distance between the particles? Gases are easily compressible because the spaces between the particles are large. When pressure is applied, the particles move closer together. This particle and this particle and this particle uh, move closer to each other if I pressed gases. What about this experiment? If you press the balloon filled with air, gas particles come closer together because of the spaces between them. This means that gases are easily compressed. The last terms are kinetic energy and the forces of attraction between the particles. Actually, kinetic energy is the energy that makes particles move. Of course, the more kinetic energy a particle has, the faster it moves and the farther apart the particles become. The forces of attraction are the forces that hold the particles together, this and this. And stronger forces of attraction, the greater the bonding and attraction between the particles. Now let's move on the terms. In solids, the particles don't have enough kinetic energy to overcome the forces of attraction between them. The particles are packed closely together and can't move around. They only evaporate in fixed positions. This explains why solids have a definite volume and shape. It also means that the particles of solid have low energy and strong forces of attraction between them. What about liquids? In liquids, particles have enough kinetic energy to partly overcome the forces of attraction between them. Okay, I mean partly. Okay, they can move around each other, but they can't separate completely. This explains why liquids can change shape but have a definite volume. It also means that the particles have a greater kinetic energy and weaker forces of attraction compared to solids. In gases, particles have a lot of kinetic energy. They can completely overcome the forces of attraction between them and move apart. This explains why gases have neither a definite volume nor a definite shape, and they separate throughout the space they occupy. From this, okay, we conclude gases have much greater kinetic energy than solids and liquids, and there are almost no forces of attraction between their particles. Okay, this table shows what we learned today. You can review and study it again to help you understand, compare, and remember the states of matter. I hope the lesson was clear, easy, and fun. I will see you soon with the next part of this. Thank you for watching.